Let's look at the equation of a line. So the example says a line is parallel to 5y minus 3x plus 6 equals 0 and passes through the point 2 minus 1. Write down the equation of the line, giving your answer in the form ax plus by plus c equals 0. So we start off with this equation here, which is 5y minus 3x plus 6 equals to 0. And now we're going to rearrange this in the form y equals mx plus c, which is the general form of the equation of a line. And so what we do is we add 3x to both sides and take away 6 from both sides. So we end up with 5y equals to 3x minus 6. And then finally divide both sides by 5 to give us y equals to 3 over 5x minus 6 over 5. And so now we have this equation in the form y equals mx plus c. Now, any line that is parallel to this line here will have the exact same gradient as the line that we have. And so in this case, if we're trying to work out the equation of the line that is parallel to 5y minus 3x plus 6 equals 0, then we know that the gradient must be the same as the gradient of this line here. And so the gradient of this line is equal to 3 over 5. So we're going to label m, which is the gradient, as 3 over 5. And so the new equation that we have for the line that we're trying to work out is going to involve using this gradient as well as the point that the line goes through, which is 2 minus 1. And so since we have a point and we have the gradient, we can use the following equation to work out the equation of the line. So we have y minus y1 equals to m brackets x minus x1, where x1 and y1 are the coordinates of the point that we have. So in this case, x1 is equal to 2 and y1 is equal to minus 1, and m is the gradient. And so substituting our values into this, we end up with y minus, so instead of writing y1, we're going to write minus 1. So in brackets, minus 1 equals to 3 over 5, and then in brackets, x minus x1. So x1 is equal to 2. If we now expand the brackets, so we have y plus 1 equals to 3 over 5x, so that's expanding this bracket, and then 3 over 5 times minus 2 gives us minus 6 over 5. Now, since we want our answer in the form ax plus by plus c equals to 0, we're going to rearrange the equation so that we have all of the terms on one side and so that the equation equals to 0. And so we're going to take away y and we're going to take away 1 from both sides, which will give us, so writing 3 over 5x on the left hand side now, we have 3 over 5x minus 6 over 5. And now we're taking away y, and we're also taking away 1, and all of this will equal to 0. So if we rewrite this in this order, then we have 3 over 5x, and now we're going to write minus y, and then we have minus 6 over 5 minus 1, which equals to 0. Now minus 1 can be written as minus 5 over 5. And so taking away these two fractions, we end up with 3 over 5x minus y minus 11 over 5, which equals to 0. And so we've written the equation of the line in the form ax plus by plus c equals to 0, where a is equal to 3 over 5, b is equal to minus 1, and c is equal to minus 11 over 5. Just to be absolutely clear. The second example says line L has the equation y equals to 5 minus 2x. Find the equation of the line perpendicular to L, which passes through the point P, which has coordinates 3 minus 1. Write your answer in the form ax plus by plus c equals to 0. So again, with this question, we start with the equation that we're given. So that's y equals to 5 minus 2x. And we write this in the form y equals mx plus c, which is the general form of the equation of a line. And so we see that currently the line is not in this form. We need to switch these two terms around so that the term that has x in it is first. And so if we switch the two terms around, we have y equals to minus 2x plus 5. And so now, comparing this with the general equation of a line, we see that m, which is the gradient, equals to minus 2. Now, if we're trying to find the equation of the line that's perpendicular to L, in other words, the line that's perpendicular to this equation here, then the fact we need to know is that the product of the gradients of the two lines should equal to minus 1. In other words, if we take the negative reciprocal of minus 2, then we can find the gradient of the line that's perpendicular to this line here. In short, if we have two lines that have gradients m1 and m2, and we take the product of the two gradients, and if this equals to minus 1, then the two lines must be perpendicular. In this case, we know one of the gradients, which is minus 2, and so we're trying to work out the gradient of the line that's perpendicular to L, and so we use this equation. So let's substitute minus 2 in. So we have m1 multiplied by minus 2, which equals to minus 1. And so if we're trying to work out m1, which is the gradient of the line perpendicular to L, we divide both sides by minus 2. And so m1 equals to minus 1 over minus 2, which is the same as a half. And so hopefully we see that minus 2, if we take the reciprocal of minus 2, we get minus a half. And then if we apply a negative to that, we get positive a half. So in other words, taking the negative reciprocal gives us the gradient of the line that's perpendicular. We have the gradient of the line perpendicular to L. We also know that the line passes through the point 3 minus 1. And so since we have the coordinates of a point and we have the gradient, then we can work out the equation of the line using y minus y1 equals to m brackets x minus x1, where x1 and y1 are the coordinates of one of the points on the line. So in this case, x1 would be 3 and y1 would be minus 1. So substituting our values in, we find we get y minus, so in brackets, instead of writing y1, we're going to write minus 1, which equals to the gradient. So the gradient of the perpendicular line is a half, and then in brackets x minus x1, which is 3. And so if we expand the brackets, we find we get y plus 1, which equals to a half x minus 3 over 2. And so since we require our answer in the form ax plus by plus c equals to 0, we're going to rearrange this equation so that all of the terms on the left-hand side appear on the right-hand side. And so we take away y from both sides and we take away 1 from both sides, and this gives us a half x minus 3 over 2 minus y minus 1, which equals to 0. So if we rearrange the terms, we end up with a half x minus y minus 3 over 2. And now instead of writing minus 1, we're going to write this as a fraction where the denominator is equal to 2. So that would just be minus 2 over 2 equals to 0. So if we simplify this, we end up with a half x minus y minus 5 over 2, which equals to 0. And this is the equation of the line that is perpendicular to L.